All right, our stream manipulators, which we were calling I/O manipulators, or I was because you #include I/O manip. Set width tells how many spaces that your output should occupy. And then set precision, if you want to make your floating point numbers only display 1 or 2 decimal places. And then left or right in order to right or left justify them. And why do you use this stuff? In order to make it all line up in nice pretty columns. Working with characters and string objects. So when you use CIN, we've been dealing pretty much with numbers. Maybe we asked for our name and we printed our name out like on the very first day of class. And since then, I don't think that we've been using CIN with strings. And what are strings? You know, letters, words, names, addresses, that kind of stuff. CIN lets you fill in strings as easily as it does anything else, but it doesn't let you type in spaces if you want to fill in a string like with first name, last name, you know, because it does what's called tokenizing. Parsing. It ignores all the white space, so that if I did this, cout name please, and then CN into name, but I type Joe Bob, then all name is going to equal, after that's done, is Joe. And then Bob is going to be left sitting there in the buffer so that, you know, if I do something like cout, enter your age, and then CN into age, well, Bob is still sitting there waiting to be read. So it's going to try to fill in age with Bob, which is not going to work at all. And so our program's probably going to break pretty badly at that point. There is a way where you can read in an entire line of data in one fell swoop. Get line. So our problem is that CIN with the stream insertion operator, our technical name for the arrow, passes over and ignores leading white space, being tabs and spaces and hitting the line key, enter key too many times. So here's an example of doing this. Please enter your name. CIN, get line, parentheses, and then you pass our input stream in, CIN, followed by the variable that you want filled up. And then cout, enter the city you live in. Get line, CIN city. That way we can enter a first and a last name, and if our city has 2 names in it, Oklahoma City, Midwest City, Del City, it's very likely around here that does. That way when we do print hello name, it'll say hello, Joe Roberts, you live in Midwest City, or whatever. It lets us enter spaces into it. If you want to read a single character, like strike any key to continue, you can use the stream insertion like that, but that doesn't let them press the space bar. It doesn't let them hit enter to do it. You know, it ignores certain things. It would work if you did press any key to continue and they typed in an X or, you know, something like that. But the most natural ones that people like to hit, enter and space, it would not work. So there's another function we could call, cin.get. Now, what kind of annoys me is that we use get line, CIN, comma, and then the variable that we're filling up to get a whole line. But if we want to get a single character, it's not something like get car CIN dot whatever. I misspelled that. Get, you know, care. To me, that would make too much sense. It doesn't do that. Instead, it uses CIN dot get, and you pass in the name of the variable that you want filled up. So in this case, string, name had better be a string for this to work. And char had better be a character. C-H-A-R. So let's try these out. Oh, by the way, some of y'all are going to be getting license expired on your Visual Studios. When you downloaded it through what used to be called DreamSpark, what is now called, excuse me for forgetting, Imagine. When you go there, if you do look up previous downloads or previous orders or something like that and click on it, you will see a installation key that you can then go and register Visual Studio. You'll see a registration key, and once you do that, then it's off its trial period and you won't ever have to worry about it again. And I meant to go through and screenshot that. I have not done that yet. I will do so by Wednesday. Just log back in with your name and password, go and find a place where you show your previous quote purchases or downloads, and then you should be able to click on it and you'll see your license. Alright, so file new, project, empty project, pull up my boilerplate, add new item. There we go. Since I'm dealing with strings, I need to add # include string. So string name, and then character CH. Why CH? Just short for character. All right, let's ask for our name. Cout, please enter first and last name. Let's let them type it in. Get line, CIN, comma, followed with the name of the variable that we want to fill up. Then let's tell them to press any key for something awesome. We're a little overbilling it a little. I broke it up into 2 lines. Certainly not necessary for you. So then we're going to use cin.getch to let them press in any key. cin.getch, pass in that variable. Ew. What have I done wrong? Oh, it's just get, excuse me. Then once they hit enter, we're going to say, you are awesome, comma, followed by the name. Followed by a couple of explanation points. /n. Sorry I messed it up. I just want to make sure that I don't have any egregious syntax errors of my own. Alright, please enter first and that last name. Joe Cool. Press any key for something awesome. I'm going to press the P key. Ew, and it didn't work. I guess I'll just hit enter. You're awesome, Joe Cool. That did not quite do what I was expecting it to do. I want to run it again. Well, press any key seems to require hitting enter after it. Or just hitting enter. Okay. Kind of odd. To me, that doesn't seem like any key. Because if I press, C, space, D, it keeps doing something. So this is kind of oversold. All right, everybody get that typed in, or we got syntax errors we need to correct. Okay. I'm going to change this from press any key to press enter, because it was not working where you could press any key. To read a single character, use CI to get. We'll read the next character entered even if white space. And their example was, there is no example. I guess I made that up in my head. Yeah, strike any key to continue. That's their example. It doesn't work. All right, forget their example. Still, that would read in a single character. And I guess the rest of it would be left in the buffer. I'm curious about that, so I'm going to add one more little bit of code here. After the cout, I'm going to try reading back into name, just to print out name. You don't have to add this. I just am very curious as to what happens if I type more than one character where it says press enter key for something. So I'm going to run it, enter first name, Joe Bob, and then here I'm going to hit the space and hit enter, and it says you're awesome, interesting. Okay, I'm a little lost on that. I'm not going to be using .get myself. See here, they're cheating. Press enter to continue, not press any key to continue. You could implement press enter to continue. Okay, I guess that's fair. That is a good way of implementing press enter to continue. The way we've been doing that before now was to use the system pause command, which is not a real good way of doing it. This would be a better way of putting in a press enter to continue prompt at the bottom of your program. So mixing CIN arrow and CIN.get can cause input errors that are hard to detect. So what you might want to do is to wipe out your input buffer so that nothing is in there with CIN.ignore. And I'll show you why you might want that. Let's ask for some dummy information. Your age. Now let's make two variables, age and height. So we're going to read into the age. And then we're going to see out your height. Then we're going to read into height. And then let's just write out their age, followed by a space, followed by their height, in lieu of doing anything more interesting with it. Followed by an ENDL. I forgot a pair of less than signs before the variable height. I did that. Let me test it and then I'll bring it back up. Okay. There are times when you don't trust what's sitting waiting there in the buffer. If it says your age and they type 38 space years, the years is going to totally mess up the reading of that height variable. In which case you may want to clear the buffer after you've read in the age. I know some people are still typing. I'm going to give you a little bit more time before I run it because it hides what's on the screen. But just like we discussed, arrow only brings in one chunk of data. Everything up to the next inner key or the next tab or the next space. So if they type in two things, then whatever was left is waiting there to be sucked in by this one. And maybe that's okay. Maybe it is. So I'm going to run it again. I'm going to demonstrate that. Please enter first and last name, Joe, Bob. Press enter key. You're awesome. Age 17. And then if I type in something else like height 6, you know, so I've typed in 17 space 6. What it displays is your height. It doesn't let us type in anything because there already was a 6 there. Maybe that was right, 6 feet, whatever. If I run it and I type in something invalid, like my age is 32 years, Joe, Bob, 32 years. It's going to mess up. Our height is now negative 8 million, or whatever. So, we're going to clear the input buffer before this second call to CIN. We may as well clear it as soon as we've read in our age. So we can do CIN.ignore. That would just skip one character. Instead, we want to ignore everything until the \n. So CIN.ignore. I'm just going to ignore a huge number of characters. Not ignore, ignore, up to a \n. That didn't work. Single quotes. It needs to be single quotes around it. Alrighty, now if I type in something dumb like 32 years, it's not going to crash the program. It's not going to wreck the program. Joe, Bob, press enter key. My age is 32 years. Your height, see, it cleared the buffer, so it made us type in a height rather than just reading what was sitting there waiting to be read. So that's what CIN.ignore does. It can, if you find your program skipping over something that you thought you should have been able to type in, then add a CIN.ignore before the next read. And you'll see that when you start mixing getLine or .get with arrow. That's what it says. Mixing CIN and CIN.get can cause input errors that are hard to detect or debug. That's when it'd be a really good idea before your next CIN arrow to do the .ignore trick. All right. String is actually a class, which means it has functions attached to it, such as .length. If we want to get the length of the string, we can do that. We have a variable called name. Let's find out how many characters, how long our name is. Int len for length is equal to name dot size. And notice when you type that dot, it popped up a whole bunch of other methods you can call on name as well. Some of which I have no idea what they do. A lot of them I have no idea what they do. But anyways, that gets the length of the string. Why might we want to do that? We might want to pull them out character by character. You know, we might want to process every single letter in the name as we go through. When do you do things like that? Well, if you make a password program and you want to validate the password to make sure it's a good password, what are the kinds of things that when you make a password online that it insists that you, what kind of rules does it make you follow?
Number of characters, certain varieties of characters.
Yep.
Doesn't match your username, things like that.
Right. So you have to have a mix of uppercase and lowercase letters. You have to have at least one number, one special character, that kind of stuff. So in order to do that, you're probably going to want to process that string starting at the first character and then going on through it. And so that's why the length would be useful. You can add two strings together with the plus sign. Be careful about that. If you do this, if you have string S1 is equal to 10, and you have string S2 is equal to 20, maybe it seems obvious, but if you did this, string S3 is equal to S1 plus S2, that does not equal, quote, 30. It equals 1020. The plus sign does something different when you're dealing with strings than it does with numeric values. When you're doing numeric values, it adds them together. 10 plus 20 would be 30. Would be 30. But when you do it with strings as your parameters, as your operands, then it concatenates them. So after this was done, S3 would equal 1020. More mathematical library functions. I don't think we're going to use very many of these. But you include the CMath header file, which sometimes seems to be included by default and sometimes not. I can't explain why. So you may as well include it. Just do # include CMath up at the top. And that gives you access to math functions. Sine, cosine, tangent, square root, log, ABS, and a whole bunch of others. ABS standing for the absolute value. More mathematical library functions. If you want to generate random numbers, like for a dice game, then you can tack on another header file, which gives you an RAND function.
Can you set a range?
Yes. No. I believe that there's a different library that will. What this one does is it gives you a value between 0 and the largest int, 2 billion. Then when you want to get that down to a range, you modulus it by your value. Let's go ahead and play with that. So I'm going to scroll up to the top and do # include CMath and # include CSTD LIB, C standard library. And I'm going to tack some code onto the top rather than the bottom, just because it's easier to spot. Let's get a random number. Int R for random is equal to RAND parentheses end parentheses. Let's print it out. R equals, followed by the value of R, followed by ENDL. But that number is between 0 and 2 billion. we want to get it down to, I don't know, if we're playing Pathfinder Dungeons and Dragons, we want a number between 1 and 20. If we're playing Yahtzee, we want between 1 and 6, that kind of stuff. So, let's change it to something between 1 and 6. So I'm going to make a variable called D6 is equal to R modulus 6. That changes it from whatever it was to a value within the range 0 and 5. And how am I going to change the number 0 to 5 to be 1 to 6?
7.
Just going to tack, nope, because that would make it 0 to 6.
Oh.
So we're going to just add 1 to it. Now let's do the D20 in a similar fashion, a 20-sided die is equal to R modulus 20, but that generates a random number between 0 and 19, plus 1 to get it up to be 1 to 20. And let's write those numbers out as well. So, R wound up being an unusually small number in my mind. If you have a choice of numbers between 0 and 2 billion, coming up with 41 seems rather remarkable. But, applying our little mathematical function, modulus, got it down to be a 6. And we could run this over and over and over to validate that those values really would never exceed 6 or never exceed 20. Wait, it's always generating the same random number. That's because it's not a true random number. In fact, you can't get a true random number with any of these libraries that come with programming languages. What they give you are pseudo-random numbers. What does that mean? It means that it generates the same sequence every time. Let's write a little loop that generates 20 random numbers in a row, printing them out. So, int x is equal to 0, while, not that we've done a lot of loops, but, you know, we're allowed to do stuff we haven't seen before. I think we've done a little bit of these. C out REND, followed by an ENDL, and then add 1 onto x, x plus plus. That'll just print out 20 random numbers, and we're going to see that they're the same every single time. Not very random, are they? Well, it's a formula that if given one number in the series, calculates something that is impossible to predict for the next number. And then it uses that number as input into that same function to calculate the third number in the series and so on. But it's always starting with the same value. That's what's known as a seed value. The way you get around that is you need to seed it with a value that the user has really no way of controlling, such as the number of seconds since midnight, you know, or number of milliseconds since, you know, the program was first run, or something like that. So I would expect that to be the next slide we see, is to how to seed it right here. srand initializes the random number generator with a number. So before we call our first rand, let's just do srand and then put in a value here. Your favorite number, 100. Now they're going to be a different sequence of numbers. It'll be the same different sequence, if that makes sense. But this time it started off with 365. Every time I run it again, it's going to start off with 365. If I change the seed, it's going to generate a totally different sequence of numbers. Here I said it was going to be between 0 and 2 billion. I must have misread that because it looks like it's between 0 and 65535. The maximum value of 2 bytes, 16-bit number. Let's go back and read this again. The largest int is 2 billion. Okay. I don't know where they get off saying that. It's obviously much smaller than that, but the idea is the same. So, in order to seed it with a better value than that, although the PowerPoints don't show that, we can get that done really quickly. SRAN seed time C++. There we go, because I want to seed it with time. So we're going to have to see if the time function is already included. What time does, gives the time in seconds since the, quote, Unix epoch, which is a pretty good unpredictable seed. The Unix epoch, whatever. It's going to be a very large value. Let's go and try that. So here, where we did SRAN, where we seeded it, replace that 100 or 1000 or whatever you have with that. And of course it doesn't know what time is. Doesn't know what time it is. Pound sign include time. Could it possibly be that easy? Time.h. Okay. The fact that it says .h implies that there are no classes in it. It's an old school C library rather than a C++ library with classes. Now every time I run it, it should give me different values. This time it gave me 17649 as my first value. This time it gave me 17688. Wonder why it's always 17. 17704. I guess it's because it is based on the number of seconds. I wish it was a little bit more random than that.
Could you alternate which time zone?
Yeah, you could do some permutation. I'm not thrilled that it's that predictable, and also not thrilled that it's limiting it to values less than. It may not even be 65535. It looks like values less than 32,000. Not that that matters. There are other random libraries where you can specify a range, or where you can specify a maximum number, and you don't have to do this kind of rigmarole. What I would do if I was going to write some code that needed to generate a lot of random numbers is I would write my own function to encapsulate this, so I didn't have to have that in there every single time. I'm not going to ask any questions on the exam about random numbers, but as we go on, it'd be kind of fun to, program guessing games or, dice games or whatever, where random numbers would make it fun. Hand tracing a program. I don't really ever do hand tracing, to be honest, because I use the debugger instead. The idea behind hand tracing is you just print out the code or whatever and you look at it, and then you step through it in your mind, writing down what variables get changed. And I'll show you what I mean. And don't type this in. This is just going to be totally. Okay, this is silly code, but I'm going to change this 20 to like 3 or 4 because I don't really feel like adding it up 20 times. What I do is I create kind of a mental spreadsheet of my variables. Sum and counter. What does sum start off as?
0.
Starts off as 0, and the counter starts off as 0. There we go. All right, then we get down here. While counter is less than 4. Is it? It sure is, because it's 0. Sum equals counter plus 1. Alrighty, sum is equal to counter plus 1. What does sum turn into then? 1. And then counter plus plus. That changes into 1. Then it goes back up and it checks. Is counter less than 4? It sure is. So it loops again. Sum is equal to counter plus 1. I should have made a sum plus equals or something. But you know, you're getting the idea. Counter plus 1, well, counter is equal to 1. So sum becomes 2. We add 1 to counter, counter becomes 2. We keep repeating this. It comes back up to the while statement. It's still less than 4. Sum becomes 3. Counter becomes 3. Comes back up here. It's still less than 4. Sum becomes 4. Counter becomes 4. It comes back up here. Is counter less than 4? Not anymore. It's equal to 4. So it bails out of the while loop. That's the idea of hand tracing a program. Just writing down your variables and stepping through it mentally, line by line. Or you run the debugger. The debugger means you set a set point where you want the program to stop. There, I have a break point now. So when I run the program in debug mode with local Windows debugger, it's going to stop there. And then I can use these little arrow symbols. Step over is the one that looks like a, I don't know, a circle going around a square. There, I've stepped over that. Sum is equal to 0. I hover my cursor over it and it tells me. I step over the next one. Counter is also equal to 0. I step again. Okay, I step again. Sum is equal to counter plus 1. Well, what did sum become? Sum is now equal to 1. And if I go down here, there's a window full of my variables. I could watch them increase as I step through it over and over and over. And it's going to keep going, not that you can see it, until until counter becomes 4, large enough to bail out of the loop. When that happens, it comes down here and it starts doing all the other stuff. I'm going to press the red square to stop debugging. We need to practice on that. You need to become good at debugging your own programs. For the most part, right now, our debugging has just been fixing syntax errors. But our programs are going to get, increasingly complicated. A case study. General Crates Incorporated builds custom designed wooden crates. You've been asked to write a program that calculates the volume, the cost, the customer price, and the profit. Oh my. So, this is suggesting that we could do it in this fashion. We would need a variable called cost per cubic foot, and then a variable called charge per cubic foot, which apparently we charge more per cubic foot than it costs because we want to make a profit. Then we ask the user for the length and the width and the height of the crate. Based on the length, the width, and the height, we calculate the volume, which is just length times width times height, right? And then once you have the volume, you can calculate the cost just by multiplying the volume by the cost per cubic foot. You can calculate the charge because that's the volume times the charge per cubic foot. And then the profit is the difference between those two. Hopefully you're charging more than it costs so that you get a profit rather than a debit. Don't really think we need to cover that. Which means that we're going to be at the end of Chapter 3. Okay. I'll post a quiz tonight. Almost hate to let us out this early. Let me go check something. Well, it won't take us much time. I did not mean to close Visual Studio. To write a little guessing game type program. Let's at least flesh out the idea of the guessing game program. Start a new project. But we really needed all of the pound sign includes from the last one, so I'm going to have to recreate them. Add new item. Grabbing my boilerplate, copying it in. I also know that I'm going to need CMath, pound sign include CMath, pound sign include CSTDLib, and pound sign include time.h. So logically what we want our program to do is pick a secret number between 1 and 100. Then we need it to loop until the user guesses the number. I'm not going to take time to pseudocode this out because I have it in my mind. Let's go ahead and pick the random number. Int secret. I haven't seeded the thing yet. That's okay. Until we do seed it, it's going to pick the same random number every time, and that's okay for testing. So int secret is equal to random. Now we need to make that number between 1 and 100. So secret is equal to secret modulus 100 plus 1. Then we need a variable to store our guess, but we're going to initialize it to an implausible value that does not match the secret. Why? Because we need a while loop that's going to keep repeating as long as the guess does not equal secret. And if the random number by chance happened to equal this guess value that we've initialized it with, it would bail out of the while loop immediately and they wouldn't get to play. That's why we made guess equal to an invalid value. It's not going to be between 100 and 1. So while guess is not equal to secret, we're going to tell them what to do. I'm thinking of a secret number. Cout between 1 and 100. What is it? Or guess. Now we can use CIN to read into our variable called guess. Now let's check. Did they get it right? Or let's check to see if they got it wrong. If guess is not equal to secret, we're going to print bzz, wrong answer. We're rude. Wrong. It's going to keep looping until they finally guess it correctly. Once they guess it correctly, it will exit the while loop. So we can put a message down here at the bottom that says, you did it, or you guessed it. Alrighty, now I don't remember the first number that this thing was generating, especially based on 100. It was 41, I think. Wasn't it always generating 41? Nope. Bzz, wrong. 42. You guessed it. Well, what do you know? I got it in 2 guesses. That's unlikely. But that's kind of a lame program. For one thing, it's the same number every time. 41. Bzz, 42. You guessed it. I'm getting suspicious. I'm going to type in other values. 98, 99, 96. Okay. So it seems to be working. But what would make this a better game besides the idea of the number not being predictable? Well, let's go ahead and make the number unpredictable. Between the RA and D parentheses, do time, parentheses 0. Oh, that doesn't belong there. We need an SRAND statement. I forgot that that's how we seed it. So above that line that says secret, do SRAND and fill it with the value of time, parentheses 0, which is a system call to determine the number of seconds since a certain time in history. All right, now it should pick a different value each time. So if I type 42, it better not tell me I got it right. Bzz, wrong. Okay. 76, bzz, wrong. I get frustrated. 1, 2, 3, 4, 5. That's pretty lame. What would make the game more entertaining or to make it easier for you to guess?
Can it tell you like higher or lower?
Yeah, it needs to tell you higher or lower. We can do that here in this logic. I know I'm going too fast for some people, but it's really only going to take 2 more edits. Instead of guess not equal to secret, make it say guess less than secret. And if guess is less than secret, we're going to say guess higher. Then we need another if statement. Else, if guess is greater than secret, see out guess lower. That should do it. The other thing we could do is keep track of the number of guesses, but I think that that's kind of superfluous at this point. 50. It says guess higher, 75. Guess higher, 99. Guess lower, 88. 92. 94. 96. I got it. Okay, and yours is going to hopefully come out different. All right, I'm going to make a Dropbox for this so that those of y'all who have typed quickly can do it, and then I'll bring the code back up and I'll wander around and help correct typos. All right, there is a Dropbox G. If you can find both of your CPP files, upload them. Otherwise, just upload this one.
What if you just put it in one?
Yeah,
Okay.
yeah. If you did it all in one, that's totally cool. And once you get it uploaded, you can bail.